problem 895 maximum frequency stack. So for this problem, we need to design a stack-like data structure to push element to the stack and pop the most frequent element from the stack. Yeah. So basically, we're gonna have this frequent stack class, and we're gonna have the init push and pop. So for the push, we're gonna push an integer value onto the top of the stack, and for the pop, we're gonna remove and return the most frequent element in the stack. So the condition is that if there's a tie for the most frequent element, so the element closest to the stack's top is removed and returned. Yeah. So this is also important. So this means if there's a tie, we're gonna use some method to record which one are gonna be close to the top. Yeah. So for this problem, as we need to get the maximum frequent stack. Yeah. Basically, we need to get the maximum frequent element. So this means it is on top of stack. If we want to pop, it must be the maximum frequent element. So how can we do that easily? So normally the basic idea is that in Python we're going to use a sorted list. So from the sorted containers import sorted list. So this is my first idea. Definitely I gonna need a sorted list. So this is gonna be my stack. So secondly, as I need to count how many of each of the elements. For example, this number 5, so currently there's 1, and up to here, if I put another 5, it's going to be 2. If I put another 5, it's going to be 3. How can I record that? And normally I need a dictionary, so this is what I designed. So I'm going to use a default dict, and it's going to be integer. And thirdly, as if there's a tie, I need to find the most frequent element. The element should close to the stack's top. Yeah, close to the top of the stack if there's a tie. So how should I do that? Normally I can use an index, or I can use a counter. So I can use index maybe. I'm going to use an index to record which one is closer to the top of stack, because from index 0, 1, 2, 3, 4, so definitely 4 is more close to the top of the stack. Yeah. Now we can start do the push operation. Yeah. So, but before we push it, let's just prepare the dictionary first. So, if val inside the dictionary, we're gonna update the dictionary self.d with this value gonna plus equal to 1. Yeah, because for this value we're gonna count it. Yeah, we're gonna plus 1. Otherwise, if it is not inside, so self.d val gonna equal to 1. So this is what we needed to do. Yeah. And now we're gonna have a counter. So our counter is d with this value. So self.d value gonna be the counter. It means how many elements. Now we want to put it inside the stack. So self.stack, we're gonna add, as this is a sorted list, so we're gonna add a tuple. So inside it's gonna be a value. So the value gonna be self.d with this value. And I also need to prepare an index, because if there's a tie, I'm gonna choose the most close index to. I'm gonna choose the index close to the top. Let me explain it here. So for example, this is my sorted list. I have a value. So this is my frequent. So for example, the frequent is 3. So for another one, maybe the frequent is also 3. But yeah, so this is for this value's frequent. And here I'm gonna have a value. So for example, this value gonna be 5, and this value maybe gonna be 6. So this means there's a tie. This is 3 equal to this 3. Yeah. So this is the maximum frequency, and this 3 is also the maximum frequency if there's a tie. So which value should I choose? Is that 5 or is that 6? Yeah. So here is just the push, but if we were to pop it out, which value should we choose? Yeah. So this is why we're gonna use an index to design it. So for example, if this index maybe, I'm not sure, maybe this is a 4, or maybe this index is a 10. Yeah. So this tuple is inside of the sorted list, this tuple is inside of the sorted list as well, but this is equal, this is equal. So for me, I need to pop out this number because this 10 is bigger. Normally for the sorted list, for the next tuple, this is one tuple, the next tuple gonna be 3, 10, and 6. So basically I need to pop out this value 6 instead of this value 5. This is what I prepared for this self.I as my index. Yeah. Now I need to put the value inside of the tuple, and after that I need to update the index. It's gonna plus equal to 1. Now we need to pop out the element. So for the element, it's gonna be a count, an index I, and a value gonna be equal to self.stack.pop. Yeah. So we need to return this value. Yeah. But before the return, we need to update the dictionary. So self.d with this value gonna minus equal to 1 because we pop out one of the value. It is this value. So basically this means the count of this value. So d with self.d with this value gonna minus equal to 1 because basically we pop out this value. So for example, before the value is 3, if we pop it out, so this means for the dictionary for this value 5. So how many of them? It's gonna become 2 instead of 3. So this is exactly what we are doing. Now let me just run it to check. As you can see, it works. Now let me just submit it. Yeah, as you can see, it passed for all testing cases and it's pretty fast. Now let's analyze a little bit about the time complexity. Because there are going to be 2 times 10 to the power of 4 calls of push and pop. And for each of the push and for each of the pop, it's going to be log n time. So the time complexity is going to be n log n. Yeah. So this is n, 2 times 10 to the power of 4, and for each of the time, it is just log n. If we are using the stack.add or stack.pop, it is basically log n time. Yeah. I think that's all about it. Thank you for watching. See you next time.